looking at number 2, right? And what is this question asking about? Let's read it. The equation of a curve, blah, blah, blah. This is an equation of a curve. You see, when you read a question, I've always said this and I'm saying it again. You are skimming. You are not reading. There's a difference. There's actually a big difference. It's like you and I are saying the same thing, but we are not reading the same. Like when you're reading, you're going, the equation of a curve, but I'm just looking for keywords, okay? I just saw the word equation and I saw curve. That's only the one I saw. And I saw it. And I saw the equation. I'm not going to lock my mind and try to do in-depth reading. And that is not even the question anyway. The question is this one. Find the gradient of the curve. So this is actually the question. Find the gradient. If I say to you, read the question, don't read the equation of a curve. No. The question is find the gradient of the curve. The only way to find gradient is by differentiation. The gradient of a curve. Because the gradient of a curve changes every single point. Look, it goes like this. This is a changing gradient, okay? It's increasing. You can have one which decreases, but it's still changing. The only gradient which is constant is a straight line. So the gradient is changing, right? You all agree with me. This is a curve. The gradient is changing, and the only way to get it is by differentiation. So this is a differentiation problem. So yes, everybody agrees that this is a differentiation problem. Now let's talk a little bit about that differentiation thing. I told you, and I will tell you again this time, that there are two different sections in differentiation which you must never cross or mix. You must see them differently. Number one is the method, the methodology, where you are being trained to know all the different methods we have of differentiating. Then number two is the application, where we ask you to find gradient of a curve, equation of the tangent, equation of the normal line, stationary point, the nature of the stationary point, where we ask you to do the rate of change of something and some connected rates of change. All this is now application. It is not going to teach you how to differentiate. You are now using the derivative to find these things. First, you get the derivative. And to find, for example, the stationary point, you are going to make it equal to 0. That is not differentiation. From then on, you are doing something else. You need to have found the derivative. Using what? Using the methods. So first is methodology. Then from methods, it's now application. Those two are different. What are the methods? Let's see the picture. So for you to know the methods, remember we always use this. The 5 types of functions you gotta know, right? We use the word light. Remember the word light tells you 2 things. Number 1, the 5 types of functions, and it actually tells you in their strength, in the order of their strength. Because when you're now integrating and you want to choose U, if you're integrating by U sub, or if you're integrating by parts, rather, not by U sub, by parts. If you're integrating by parts where you have 2 different functions multiplying, you need to know who you make you use this order. You check, is there ln? L is for ln x, okay? Only ln x. I is for inverse trig, and you only do tan inverse of x at A level, okay? Then A is algebraic. Algebraic is just the functions with x squared plus 5x minus 2, or whatever it is, okay? Even to say square root of x plus 2x minus 9. This is another algebraic function. It's just x and its powers, those simple ones, where you use the power rule to differentiate. So for here, we'll change this square root of x to be a power so that we can use the power rule. Power rule says drop the power and reduce it by 1. Okay, so this x square root of x would be an x to the half. That's the power. Then you'd now be able to differentiate it. Anyway, T is for trig, which are 6 trig functions. You have to know how to differentiate all of them. So this year, first you are taught, we call them common derivatives. And we teach you by giving you a table. A table which shows you the derivatives of all these guys I'm writing right now. So you have to know, okay, there is sine x, there is cos x. You need to know its derivative. There is tan x. You need to know its derivative. There is sec x. You need to know its derivative. There is cot x, you need to know its derivative, and there is cosec x. Now for A level, you are given that table in the exam, right? The common derivatives table, you see them saying derivatives. It's an MF19, we'll talk about it. Then for exponential, you only have to know e to the x. Now here are that's the first thing. This is the first thing. What is the first thing? The first thing, remember, come on. The first thing is to know the derivatives of all these 5. It's part of methodology. It's not the whole thing. First, I'm teaching you methodology, okay? Which are the methods of differentiation, okay? Before applications. The methods is number 1, common derivatives. Which are derivatives of these 5? Lie-8, isn't it? And the derivatives for polynomials, we said you learn them by knowing what we call the power rule, right? Okay, now let's say I'm done with this. Let's say I now know the derivative of ln. I now know the derivative of tan inverse. I know the derivative of sine to all the way to cosec. I know the derivative of e to the x, and I can use the power rule. I'm done. So am I done with the methodology? Hell no. Hell no. You're not done. What else should I know? You should now know the 3 other rules, which is the product rule. You must know the product rule, okay? We may apply it in this question. You must know the product rule, and you must know the quotient rule, and you must know the chain rule. Now, somebody may say to me, hey man, what is this now? Okay, where do these come in? Where are these rules coming in now? What are the rules for? Okay, so the rules are for when you are now going to be combining these functions in Lie-8. Okay, for example, if I take 2 different functions in Lie-8 and I make them multiply each other, then to differentiate that thing, I use the product rule. So product rule is now telling me how to differentiate combinations. It's no longer 1. For example, you have something like y is equal to x squared ln x. What is this? This is a combination. We have x squared is an algebraic. Ln x is a logarithmic, right? This is ln x, it's L. And then x squared is on the algebraic functions, the A. These are 2 different, and they are multiplying. You now say, how do I differentiate? Product rule, product rule, product rule, right? Because you first knew how to differentiate it alone. Now we are combining and asking you what's the derivative when it's combined. And now you now need to know the rules. That's the way they're coming. For quotient, you'd have 2 dividing. Let's say e to the x over sine x, and you're asked to differentiate this. These are dividing. E to the x is an exponential function. Sine x is a trig function. And they are dividing, and you'd now want to use the quotient rule. So you'd need to learn it and see how to use it. But here I'm telling you where it is used. That is what I'm telling you. For the quotient rule and the product rule and whatever, you check the videos on that and when I'm applying as well. Now, what about the chain rule? The chain rule is used now when you have, oh my goodness, this chain rule is so important because I can assure you right now that 90% of the functions you are going to be given in the exam, whether they are dividing each other or doing what, there is going to be a composite function where you're going to need to know the chain rule. So let's talk about that composite function. What is a composite function where I will need to use the chain rule? Chain rule is used for composite functions when you want to differentiate composite functions. Composite functions is just when we say we have a composite function or a composition of functions, it is when we have a function inside another function. So for example, I say to you, please differentiate y is equal to e to the x squared plus 5. Okay? This is a composite function. You say to me, what do you mean? This is an exponential. I'll say, what? No! The exponential was e to the x. But now this is e to the something which is not x. It is e to the x squared plus 5. That's not x. This is now a composite function. Okay? As long as you see it having something which is not x, wake up, wake up, wake up. That's a composite function. And you have to use the chain rule, right? For example, if I now give you another one and I say y is equal to sine of, now let's say x to the 5. Or sine of y is equal to sine of negative x. This is not an x. This is something which is not an x. So this makes this a composite function. We do not care what is inside. As long as what is inside is not an x, then we see it as a composite function and we use the chain rule. So this is what you're going to need to know. And here is a sneaky one. Here is a dangerous one. For example, x squared plus 5 to the power of 7. This is actually a composite function. You say, what? How? Because the polynomial was y is x squared plus 5. What is this power of 7, which is affecting everyone? What is that? Once you see it, it's now putting another function over another function, that makes it a composite function. You understand? And you're going to use the chain rule. Chain rule, I'll just show you once. What it does is, it says differentiate the outside without changing the inside, then multiply by the derivative of the inside. Okay? So that is what you do. You differentiate the outside without changing the inside. Then you multiply by the derivative of the inside. Let's see. Here, for example, I'll give you one. Let's say y is equal to ln of x squared plus 5. Now we want to differentiate this. What is dy dx? So you would have been taught the derivative of ln x first, right? Because it's there on line 8, okay? And I'll tell you now, the derivative of ln x is just of ln x is 1 over x, okay? So the derivative of ln x is 1 over x. You agree with me? Now let's come here. So we have ln of something which is not an x. So this is a composite function. Now how do I differentiate it? I start by differentiating the outside. What is the derivative of an ln? When we differentiated ln x, we got 1 over x, right? Now it is ln of something which is not x. So what is it? It is just equal to 1 over that something, x squared plus 5. But are we done? No. What do we then do? Multiply by the derivative of the inside. So now you're going to say, what's the derivative of the inside? The derivative of x squared is 2x. Derivative of 5, nada. So now we can say our dy dx is 2x over x squared plus 5. And you are done. This is going to be the chain rule. Okay, so once you know these rules, chain rule, quotient rule, I could have taught you the other rules. You know, I got tempted on chain rule and I had to explain. But anyway, there's product rule and there's quotient rule. Same thing. They're all fun and nice. Are you done with differentiation methods? No. You now have 2 more things and you are done. And you are done with differentiation. You are done. The rest is now application, which you also need to know. You also need to learn, how do you now find this? How do you now find this? But it's all, you'll be now finding it after having done the differentiation. So the differentiation is done first using these things. First, common derivatives. Okay, this one is a table. Remember, you know this from a table, right? After knowing this table, if I know this table of common derivatives, what do I now need to know? Product rule, quotient rule, and chain rule, right? What about if I now know them? Then you now need to know differentiation of implicit equations, and you got to know differentiation of parametric equations. And we'll say to you, come get a handshake, buddy. Come get a handshake. You are such a brilliant mathematician. This has been excellent work from you. Differentiation of implicit equations. What are these now? These are just equations where you cannot make y the subject. So you're going to have to differentiate with y inside. So there will be an x, there will be a y, they'll be together, they'll be stuck because you can't make y the subject. Wow. And you're going to differentiate y the same way you differentiate x, okay? But what you would know is every time you differentiate y, after differentiating it, you put dy dx, okay? And then at the end, you make all the dy dx, you make them go to one side, then you make dy dx the subject, okay? Like you factor it out, then whatever, that's what you're going to do. That's for implicit. Now, there's a trick in it, which I need to tell you. If you see them multiplying each other like this and you're differentiating, you actually use the product rule, okay? Because there'll be 2 different things multiplying. Be careful on that one, okay? And also remember, when you differentiate the y, you make it the subject. So it's like if I'm differentiating here, the product rule says you bring the second, you multiply by derivative of the first, which is by 1, plus you bring the first x, then you multiply by derivative of the second, which is the derivative of y is 1, but you put dy dx. So this is how you differentiate this. So you'd get 1 plus x dy dx. That is how you do it. In case you made it, don't say I haven't told you. Now let's talk about parametric. What is the trick in parametric now? Parametric, you'll be having 2 different equations, and they are functions of some other variable. For example, if I say to you, you have x being equal to t squared minus 5t, then you are going to have y being equal to 3t cubed plus 1. These are 2. Then we say, please find for us dy dx. Okay? Now, if you look here, can you find it? Impossible. What can you find? You can find dx dt, because x is in terms of t, right? And what else can you find? You can find dy dt, right? Now you have to combine these two to get dy dx. And you're saying, okay, since y should be at the top, it will be dy dt times, I need x at the bottom, so it will be now dt dx. Okay? But do you have dt dx? No. What do you have? You have dx dt. But what is dt dx? It is 1 over dx dt. Then you multiply by dy dt. This will give you your dy dx. Okay? So will you have dy dt? Yes. Will you have dx dt? Yes. You will say 1 over that dx dt. Then you multiply it by dy dt, and you're going to get dy dx. If you remember this, I'll say, come get a gold medal already. You are ready for this. You have to master these things though and practice, and then now it goes to application. So this is the whole of differentiation. Now we're going to use it to come to this question, which is asking us about gradient. Because we know gradient is application of differentiation. You use differentiation to find the gradient of a curve. So we are going to use one of the methods on the screen. Either Layet, okay, like the things we know, or the product rule, or the quotient rule, or the chain rule, or we are going to do implicit differentiation of implicit equations or of parametric equations. One of these, we're going to use it to find the derivative. It has to be. Then after finding it, we'll do some tricks and we do whatever. That is what is going to be needed. So this is it. Goodbye. We are going to do now the application in the next video, and we enjoy. Bye.